Hi everyone, welcome to this lecture. So in this lecture, we will learn about the intuition behind KNN, or basically we will learn how KNN works. So suppose we have two classes of a data. So this is the data which has been divided into two classes. This is our class A, which is represented by a blue color, and we have a green color of class B. Now a new point comes, which is our new test point or our query point. So this is shown with the red color. Now how KNN works in order to classify this point between two labels, that is between the class A and class B. So we have to decide about this point, whether this belongs to class A or it belongs to class B. So let's see how KNN works about this point. So what KNN can do is KNN will assign the nearest neighbor to the point. So in the first step, KNN will assign one nearest neighbor to this testing point. So this red is our testing point, and according to KNN, this green is the nearest point to this red point. So it will assign one nearest neighbor to this point, and based on that point, it will decide in the favor of the class. Since the nearest point to this test point belongs to class B, therefore, according to this classification, this test data belongs to class B. Now, what could be the problem when k is equals to 1, or what could be the problem with only one nearest neighbor? Suppose our testing point is here, and in our data set, there is also a misclassification. So we can see that this green point is a misclassified point. It belongs to class A according to the classifier. However, its original label is class B. So what happened? If our test point is at this position and we select only one nearest neighbor, in that case, we will not be able to classify it correctly. Clearly, we can see that this red point is close to the cluster of class A as compared to class B. But since we have selected only one nearest neighbor, so according to one nearest neighbor, this test point belongs to class B because its nearest point belongs to class B. So this is again the problem by selecting a very less number of nearest number, that your nearest neighbor may be the misclassified point or any noise which is present in the data. So this problem is solved by increasing the number of nearest neighbors. So we can see that here we have three nearest neighbor. So if we select three nearest neighbor, so in those three nearest neighbor, one of the neighbor belongs to class B and two neighbor belongs to class A. So if we perform the majority voting here, so according to the majority voting, the two samples or two nearest neighbor belongs to class A. Therefore, this testing point belongs to class. So here the classification of the classifier is correct by increasing the number of nearest neighbor. So based on the majority voting, we decide in the favor of class A in this particular figure. Now, when we have three nearest neighbor, this is another situation. So we can see that this is our testing point, and when we select three nearest neighbor, then based on the majority voting, we can say that this test sample belongs to class A. However, we can see that it is not easy to take three nearest neighbor here. This data sample also wants to join the nearest neighbor of this point. So the solution is to increase the number of nearest neighbor. So if we increase the nearest neighbor to 5, so we can see that we may arise these two kind of situation. So in that situation, what is happening? If we see here, these are the 5 nearest neighbor to this testing point. In that case, based on the majority voting, 3 of them belongs to class A and 2 of them belongs to class B. So based on the majority voting, this belongs to class A. If we see here, based on the majority voting, this belongs to class B as compared to class A. So here we can see that even with k is equals to 5, there might be a problem. So how many nearest neighbor we need to select? For this, we have to study the KNN algorithm in detail. So I will see you in the next lecture.